Alright, the topic for this section is Pre-Calc Review 2. We'll be mostly studying rational expressions. What are rational expressions? Again, as a review topic, rational expressions are those that have a ratio. It's the first 5 letters of the word rational spells ratio of two polynomials. So you could have a polynomial on the top divided by another polynomial on the bottom. So for example, you may have something like x squared minus 4 divided by x squared minus 9. That's a polynomial over a polynomial. It's a rational expression. You'll run into this in calculus, and you'll be doing a lot of simplifying. You'll also be looking at rational equations and learning how to solve those. You will also see in this section rational expressions that don't necessarily have polynomials but rather radical terms, and then we'll be doing what is called rationalizing the numerator or the denominator, something we had seen before except in a more complex form. So we'll see these two topics in this section. So we'll be learning how to simplify, multiply, divide, add or subtract all these expressions, and rationalize. Okay, so the first thing you want to know is never ever do anything that's against the rules of simplifying. In other words, don't cancel these. That's not how you simplify. Rather, you would factor. So taking that example, x squared minus 4 over x squared minus 9, the way you can't really simplify this any further, because if you do try to simplify, you would try to factor the top. It's x plus 2, x minus 2 divided by x plus 3 times x minus 3, and there aren't any common factors. So this example doesn't really take you anywhere. However, if you were to find on the course list, worksheet section 1.2a, here's some examples. So the first question has 3 problems that we need to simplify. Depending on the question, you may have to simplify using different techniques. In this case, we have a trinomial which we can factor using techniques from the last section. And the bottom, that's a difference of squares, x squared minus 2 squared, so it factors as a minus b, a plus b. So the top, x times x is x squared. You need a 2, factors of 2, 2 and 1. You want one of them to be negative. The smaller number is going to be negative so that it adds up to a positive 1. The bottom, factors as x plus 2 times x minus 2. The common factors that cancel are those, and you get x minus 1 over x minus 2. And remember, you can't cancel the x's because they're attached to those other terms by addition or subtraction. The next one, you notice here too, it's the 1, 2, 3 terms, trinomial again. The factoring is going to be a little bit trickier because you have a squared in the beginning and b squared at the end. The 2a squared, you can obtain it by doing 2a times a. But the 9b squared, there's more than one way. Let's try 3b and 3b and see if that works. 2a times a is 2a squared. That's 6ab minus 3ab, or negative 6ab. Positive 3ab will give you that, minus 9b squared. You should always go and FOIL that out and double check. Okay, if you can't do it in your head, it's okay. Just go off and do it on paper. So that's 2a squared minus 6ab plus 3ab minus 9b squared, and these two do combine to give you that middle term. On the bottom, these are just 2 terms, and it's not in this format, so we're going to just pull out a GCF between these 2 terms. There's a b squared that is common, but you're left with 2a plus 3b. So these 2 cancel out, and you just have a minus 3b divided by b squared. Once again, do not cancel the b's because this is connected to this term by means of subtraction. Question 1c is actually more indicative of what you will see in calculus. So how do you simplify something that looks as messy as this? Well, first of all these terms are multiplied, so that's one chunk. And there's a minus here, and these are all connected by multiplication. That's a separate chunk. So looking at these two, see what is common between those two terms. There's a 1 plus x squared squared and a 1 plus x squared. So clearly there's a 1 plus x squared that is common. And there's a 2 that's here, and there's a 2 here as well as one of those. So one of those 2's is common. So pull out the 2. I'm going to use a square bracket just to differentiate what I've pulled out as a GCF from whatever's left. You don't have to do that. From the first chunk, we took out a 2, and we took out one copy of that, so there's one more copy left. Then the minus sign. From this big chunk, we took out a 2, and we took out that part. So we're left with 2x and a 2x, which is really 4x squared, because they're being multiplied. All divided by 1 plus x squared to the 4th. Okay, now over here, this is all connected by multiplication. Okay, so this can actually cancel one of these 4 copies. So make that 3 copies. So there's a 2 left. Combine like terms. It's 1 x squared minus 4x squared is negative 3x squared, all over 1 plus x squared cubed. And you can't really go any further. These don't cancel, so you stop right there. Alright, the last question on this page is all about multiplication of rational expressions. What you don't want to do is just multiply. Well, the rule of multiplication of fractions is if you have a over b times c over d, you multiply the tops and you multiply the bottoms. But if you have something like 5, 6 times 18 over 25, normally you wouldn't just multiply and get bigger numbers, because then you wouldn't be able to simplify very easily. Instead, what you would do is write 18 as 3 times 6, and there's a 6, and it's 5 times 5, and then you can reduce. When they're all connected by multiplication, you can cancel. So you end up getting 3/5. So, going away from that analogy, let's try to factor. So you factor, and then cancel. Factor, then simplify. So the top there factors as x minus 3 times x minus 3. Check that. The bottom is x minus 3 times x plus 2. Again, check that by foiling it out. 3, it's only 2 terms. 3 is a factor. X plus 2 is left. This one's a little trickier because of the 2. So you have 2x and x. To get a 3, let's try putting 3 here and a 1 here. 2x, and that's a 6x. You need them both to be negative because you have a positive there. So 2x squared minus 6x minus x plus 3. Well, that works. Cancel that, and that. So we are left with 3 on the top and 2x minus 1 on the bottom. Going on to page 2, we have a division problem. Again, recall how you divided fractions way back when. If you have a over b divided by c over d, you simply write this as a over b times d over c. You flip that, change that to a multiplication. So we're going to factor this, and at the same time change this to multiplication and flip. So we have 3x times x, and to get the 4y squared, I'm thinking we can try 2y and 2y. So you have 3x squared minus 6xy plus 2xy, which will give you that. Again, double check by multiplying it out. Minus 4y squared, all over x squared y. Times, that goes up, that goes down. 2y minus x squared. Now this y is being multiplied, so it's legal to cancel. With the y here, and the x squared cancels with 2 copies, leaving you an x here. I'm going to circle it so we don't lose it. Now, it doesn't seem at first glance that there's anything left to cancel. However, if you look at this term, x minus 2y and negative x plus 2y, they are related. This, x minus 2y, you can factor out a negative sign from it, a -1, and write down 3x plus 2y, and this would be 2y minus x. I just flipped these two terms when I pulled out the negative sign. Okay, so I also have an x there. It's all divided by, now there's two copies, 2y minus x, 2y minus x, so that cancels with one of those. So we're finally left with negative, I'm going to slide this x in the front, negative x times 3x plus 2y divided by 2y minus x. Now, you could be fancy and absorb that negative sign and flip these two terms, but you don't have to. Our online homework system, WebAssign, will accept either of those. Alright, the next question involves addition of fractions. You may recall from, again, back in the days past, how you added fractions. You need a common denominator. For multiplication and division, you do not need a common denominator. Only for adding and subtracting you do. So look at these two denominator terms. The common denominator is 15ab. Okay, you basically need to include both those. Now the first fraction already has the 3a, it's lacking the 5b, so you multiply 5b to the top and bottom. And the second fraction has 5b, it needs the 3a, so 3a to the top and bottom, which each of those fractions will now have the common denominator. So 5b, distribute that to get 5ab plus 5b, and then distribute the 3a, so it's 3ab minus 6a, 3 times 2a, all over 15ab. Combine any like terms, which I see one set, so it's 8ab plus 5b minus 6a all over 15ab. Now once you do this, you still want to check and see, is there anything common here that you can factor out and reduce with the bottom? I see nothing, so you stop. This is your final answer. Last question on this page. You have a fraction on the top, a sum of two fractions, and there's a big fraction bar and a more fraction on the bottom. This is called a complex fraction when you have fractions within fractions. There's a couple ways to simplifying this. Remember, the directions for this are to simplify. One quick way is to treat this top as a separate problem, and this is a big division symbol, and that's a separate problem. Get some single fractions on both portions. So there the common denominator is xy. The first fraction needs a y, the second fraction needs an x, so you have a y plus x. Done. Okay, so that is being divided by this piece, and this is 1 over 1. Common denominator is xy, already here, but not here, so multiply this by xy, top and bottom. So you have xy minus 1 all over xy. And then you would switch this division and flip the second fraction, so you have y plus x over xy times xy divided by xy minus 1, and now you have a multiplication. These cancel out. There's the top and there's the bottom. Another way that you might have seen as to how to tackle this question, let me recopy the problem, is to multiply top and bottom by common denominator for both the fractions, which is xy. And then you would distribute and clean up. So if you distribute this, the x's would cancel, so you just have a y. If you distribute it here, the y's would cancel, so you just have a 1 times x. All over distribute, you have xy. When you distribute here, the xy's cancel, so you have 1. So this is the same answer as that. It happened kind of quickly, so make sure you understand how that worked. You can repeat the video, or the textbook has all the alternate methods listed as well. Last page. This is still simplify, continued from page 1. Over here you see a big bunch of terms. This again is something that you will see in the calculus part when we get to it. How do you do it? think of all this as 1 all over 1, and that's another fraction. So to simplify this, you need a common denominator, and clearly, since this is a 1, the common denominator is this piece. So you're going to multiply the first term by 2 square root of x squared plus x, and you're dividing, of course, also by it. So this gets the common denominator. So when you multiply 2 times the square root of x squared plus x to this chunk, 2 times 6 gives you 12. 2x squared plus 1 squared, I'm copying that down. Square root of that times the same term gives you x squared plus x. But notice, I need parentheses for that. Plus this term, which is 2x plus 1 to the 4th. I just realized I have an error here. Remove that x squared. It's just an x. All divided by the common denominator. Now, you can't really cancel anything, remember, because you have an addition. What you can do is on the top, this is going back to page 1, you have an addition, 2 chunks. You can factor out the 2x plus 1. There's 2 copies here and 4 copies there. Factor out the 2 copies that are common. When you do so, I'm opening square brackets again to differentiate what we factored out as a GCF. So this is gone. I'm left with 12 times this. Distribute 12x squared plus 12x, plus we took out 2 copies from here, so there's 2 more copies left. This is going back to the last section. If you have something quantity squared, you need to FOIL that out. Excuse me. So that's going to be 4x squared, and you have a 2x and a 2x, which is 4x plus 1, which I'm going to write here. 4x squared plus 4x plus 1, and then you have 2 times the square root of x squared plus x. So these two are like terms, these two are like terms. Combine those, and then you will be done. So you have 16x squared, 12x plus 4x is 16x plus 1, all divided by 2 times that. Okay, the last part of this section is going back to rationalizing the denominator. However, what's different here is that you have 2 terms. In the last section you only had 1 term, so when you multiplied by 1, you just multiplied by the radical term. But here what you need to do is multiply by 1, this 1, but you change the sign, plus the square root of a, 1 plus the square root of a. So those are the conjugates. The reason why this works is that if you were to just for a moment focus on the denominator, if you multiply this, you have 1 times 1, 1 times root a is positive root a, minus root a times 1 is negative root a, and negative times a positive is negative, root a times root a is just a. On the top you have a times 1 plus root a. These two cancel out, and you just have a times 1 plus root a all over 1 minus a. So now the goal is in this question to not have a radical in the bottom, and we were successful because we multiplied and divided by a right piece that actually canceled out the radical terms. Why did that happen? Because these were the conjugates, something I had mentioned in the last video. If you had multiplied and divided by 1 minus root a, this would not have happened. So this is the one and only correct way to answer the question. Once again, the book has more examples. The last question here is rationalizing the numerator of the expression. So the radicals on the top, and this happens quite a bit in the calculus part of this class, so we're going to practice here. It's going to multiply and divide by the conjugate of that, which is root x plus 1, root x plus 1. Now be careful to write your radicals properly. It stops here, it doesn't get long. Don't be lazy and sloppy. Again, when you do the top, I'm going to use parentheses. Root x times root x is x. When you do the outer, positive root x, negative root x, they cancel out. I'm not going to even write it. And it's minus 1 times 1 is minus 1. And then you have x, parentheses, root x plus 1. Now, questions to ponder. Did we answer the question? Rationalize the numerator. Yes, there's no square roots on the top. We answered the question. Can we go further? Can I cancel these x's? The answer is no, because there's a -1 attached to the x. So you would stop right there. Okay, winding down with the last question. Now this, again, rationalizing the numerator, you have square roots on the top. So you're going to multiply by the conjugate. Don't change anything here. It's this middle sign that you're going to change to positive root x. And then, of course, divide by the same thing to keep the balance. Multiple terms, use parentheses. Now I'm going to multiply the top. I get x plus 3 because the square roots go away. And then I don't do the outer, I don't do the inner, they will cancel out. Rather, I'll just do the last. I just get minus x. Now, in all these questions, I haven't been multiplying the other portion, like here. There's a reason for that. Here, I'm going to leave the 3 out. And you will see the reason in just a minute. On the top, x minus x, that's gone. So now you're left with just a 3, which is going to cancel out because this 3 is multiplied to the whole thing, and that's a legal cancellation. So you're left with a 1 on the top. And notice that we were able to do this cancellation because I left the 3 exposed. And that's a technique we will be needing very soon in chapter 2. So, it's the end of this video.